Hey, Dr. Realized Math and History, and we are gonna take a look at percent composition. We have been taking a look at molar masses in chemistry, and also calculating how much the compound or the element would weigh if we had 1 mole of atoms, or 1 mole of, atoms, and it would be how much it would weigh in grams. But percent composition does that, but also calculates how much of each element in that compound is going to take up that much space in percentage. Like, what is the percentage in hydrogen being present? What is the percentage of nitrogen being present? What's the percentage of mercury being present? So what we're going to do is actually solve the problem out. So what we have here is C3H6O3. That is C3H6O3. So carbon, hydrogen, oxygen. And that is known as lactic acid, the chemicals and the stuff that appear in your body after you do some kind of rigorous exercise, like running. So we are going to find the molar mass of this compound right here, CHNO. We have to understand what each of the atomic masses there are, and we can look that on the periodic table of elements. But for now, when we look at the compound, we can understand that there are 3 carbon atoms, so you have to do 3. There are 6 hydrogen atoms, so we put a 6 here, and a 3 for oxygen, so we're going to put a 3 there. Multiply that by the atomic masses. So, we have carbon right here. We need to find the atomic mass. So, here's carbon right here. So it says that carbon is 12.01. So we're going to say that carbon is going to be 12.01. If we had a mole of atoms for carbon, it would weigh 12.01 grams per mole. Now let's take a look at hydrogen, which is easily to remember because you use hydrogen a lot in the world. 1.0079. I'm going to say it's 1.008 just to round it, to make it easier to calculate. 1.008. And for oxygen, so for right here, oxygen is 15.999. We're going to round that to make it an easy 16.00. So when you add all of the numbers up, you'll be able to get your molar mass. Wait, before we add all the numbers, we still have more than 1 carbon atom, more than 1 hydrogen atom, and more than 1 oxygen. So what we're going to do is do even more steps. So 3 times 12.01, there are 3 carbon atoms. That is going to bring us to 36.03 grams per mole. And for hydrogen, that is going to bring us to 6.06. And for oxygen, easy number, 3 times 16 is going to represent 48. So now we can find the molar mass of this. If you add all of the numbers up, you are going to get an answer of 90.09 grams per mole. So that is how much the compound has. If you have 1 mole of this compound, it would weigh 90.09 grams, or its mass would be like that. But if you ever picked it up it would feel like 90.09 grams. We're not done yet because the video that we're understanding and watching is not about molar masses. It's about percent composition. How much of each atom takes up the molecule, and how much of each element is going to be present within the molecule. So, the bad news is, we're not done. So, to understand what's going to happen, we are going to put 90.09 on the bottom 3 times. But why do we do this 3 times? There are 3 different elements. And what we're trying to find is how much they are present within the entire compound. So we're trying to find a percentage. So something above here, and here, multiplied by 100 each, should be able to get a percentage of how much there actually is within this. So understanding it, if we take a look at carbon, for example, we reported that carbon is 36.03, and that is just for 3 carbon atoms. So we are going to put that right here, 36.03. For hydrogen, we are going to put 6.06, because that is how much hydrogen only is represented in this compound. Same thing goes to oxygen, and we're going to say 48 even, because that is the molar mass just for oxygen, 3 atoms in that compound. Now we'll come up with a percentage. So for carbon, if you do the math, it's going to cover 34.99%, and that is saying that carbon takes up 34.99% of the molar mass of lactic acid. If you do hydrogen, you're going to get a final answer of 6.73%. Hydrogen is usually going to have a low percentage because it's a very small molecule, it's a very small atom, and it's very, very weak. It's very hard for hydrogen to get a lot of electrons, which we'll learn a bit later, because its gravitational pull is weak and it's very, very small. The last one, for oxygen, if you do this divided by this, that times 100, you're going to get an answer of 53.28%. So oxygen is going to take up 53.28% of the molar mass for lactic acid. And that's how much there is. To check your answers, these should get you to 100%. And we have did it. We have understood how to find the percent composition of a compound, which is lactic acid, and found out how much each element takes up within the entire compound. I hope this video has helped you understand percent composition. Thank you for watching Tapping Analyze Math Industry. Like and subscribe.